Okay, so what's up, guys? This is Akshay here, and let us continue with today's question. Today's question is a very easy and a standard one as well. So we need to find the rightmost different bit. Let us read the question. So we have been given two numbers m and n. So let's go back to that. We have been given two numbers m and n. We need to find the position of the rightmost different bit in the binary representation, right? So let's just see, understand the input and output. So 11 can be written as 1011. Similarly, 9 can be written as 1001. So at this place, we'll start from the last position, that is from the rightmost. The bits are same, so we'll move back. So again, we'll come at this position, you'll see that the bits are different, right? So what's the position? So position is named as this 1, 2, 3, and 4. So this is the second position where the bit was different, and that is why 2 is returned as an output, right? Okay, so which bitwise operators helps us to identify, helps us to get something when the bits are different, right? So it's bitwise XOR. So if the bits are different, and if you do a XOR operator between them, then you get a set bit, and right. And if the bits are same, and if you do a XOR operator, you get unset bit. Let's say 0. So we will use this the fact here in our present question. So what we'll do, we will form first of all 11 XOR 9. So what will happen? 1011 will be XOR with 1001. So bits are same 0, bits are different 1, bits are same 0, bits are same 0 again, right? So that means whenever, so okay, so this is the case where we have, if the bits are different, then we got a 1, right? So definitely now the question has been boiled down to find the rightmost set bit, right? Can we say the question has been converted to this question now? You just need to traverse from the rightmost, you need to find the first set bit and need to return that position. That would be our answer, right? Now to solve this question rightmost set bit, there are two ways, right? So first is that you traverse for each and every bit from the rightmost to the leftmost. That will give you the diagonality of log n, right? You will traverse each and every bit. And the second is pretty much interesting. So let me explain you that technique. So you need to find the first set bit from the rightmost. Now, if you remember what is 2's complement, right? So I have taught you multiple times what is 2's complement and how to remember it in a trickier way. 2's complement is nothing but you have a, let's say, number n. So what you do a negation of, you find the complement of the number and you add +1. Then that's give you 2's complement. But this is a lengthy technique to remember, right? So I have made things simpler for you. So what is if I just say what is the 2's complement of this number, what you will do is just okay, so let's just do this in the manual way and then I will give you the trick. So let's just negate find the complement of it. So 0 1 0 0 0. Let's just flip the bits and do a +1. So 1 and 0 will give you what? 1. And similarly 0 0 1 and 0, right? So this is your 2's complement of this particular number. So the trick works like this. So once you have find your first one, right, you flip all the bits of the rest. Once you have encountered the first one from the rightmost, you write everything as it is and then you flip it. So 0 0 1 and 0, and you can see this is your answer. This is your second complement, right? Let's just do one more example of 2's complement. So let's say the bits are given you as 1 1 0 0 0. Please pause the video, try to write the 2's complement with the trick. So again, so what's the 2's complement? So we will go till the first one, we will write everything as it is, and once we have encountered the first set bit, we will flip all the bits. So it would be 0 1 and 0. Great, you have learned the trick for finding the 2's complement, right? If you see, what is the trick again? That after the first set bit, flip everything, right? So what we will do, what is the 2's complement of this number? It would be 0 1 and then flip everything, so it will be 1 and 1, right? Now what I need to find now, one sec. Okay, and now if I get the AND of these two numbers, that is the XOR of two given numbers with the AND of 2's complement, right? So what will be your number here? This would be 0 and then 1 and 1 and again everything 0, right? तो हमने यहाँ पे क्या किया यार? For the first set bit, we are retaining the value as it is and everything remains 0 because we are doing an AND operator with the 2's complement. I hope you got the logic. If not, please join for some more test cases and you will definitely be able to grasp it, right? Okay, now this is a number, or let's say this is the binary representation of such a number where the first set bit is only set and then rest all the bits are marked as zeros, right? So to get this position, what we will do, we will just take log of 2. because everything has the weightage in power of 2, right? So in the decimal it is nothing but 2, right? So log of 2 of 2, it will give you 1. But the indexes, but the starting, the counting of the bits, the weightage which has 2 0, that is also has the index as a 1. So in the answer we'll just do 1 plus, right? And finally the 2 would be your answer. Again, I'm saying, if you are please do some more dry run and then you will be able to get this. Let us look at the code. So this is your first method which I was talking about, that you visit each and every bit, you check if it is set or not, and if it is set, you just count, return the count, else do the count plus plus and decrease your number by number by 2. In that like that you will be able to traverse all the bits from rightmost to the leftmost, right? If that's not the case, return -1. So you can run either of the code. Please try the code as well. So method 2 is nothing but, we have discussed this thing. We get the XOR of the numbers. We had a result of this particular number and with the 2's complement, and we return the log base 2, right? That is it. Let us set the submit button. So what are the time complexities of both the approaches? So method 1 again will take you the log n and O of 1 as space. Similarly, method 2 will also give you log n because you are using math.logarithmic of result, right? So it would be, again, in both of the cases you'll get log n, but the approaches are different. Okay, great. I hope you'll be able to convert the code into C++. So I will just check out from this video. Let us meet again in the next video. Till then, keep learning, keep growing. Bye bye, and take care. If you do like the questions and the solutions, please support our community, and then let's meet again. Bye bye.